Determine whether the integral converges or diverges. Evaluate the integrals that are convergent. Let's take a look at example 1. Suppose we had the integral from 1 to infinity of 2x to the negative 3 dx. So this is the limit as L goes to infinity of the integral from 1 to L of 2x to the negative 3 dx. So this is equal to the limit as L goes to infinity of, I get 2x to the negative 2 divided by negative 2 evaluated from 1 up to L. Now, remember 2 over negative 2 is negative 1, right? So this is the limit as L goes to infinity of negative x to the negative 2 evaluated from 1 to L. But I can write this as the limit as L goes to infinity of negative 1 over x squared evaluated from 1 up to L. And remember, we haven't evaluated a limit yet. That's why that limit as L goes to infinity piece is still there. And so this is the limit as L goes to infinity of. Now, when I replace x with L, I get negative 1 over L squared minus, when I replace x with 1, I get negative 1. But I could write this as the limit as L goes to infinity of, when you subtract a negative 1, that's the same thing as adding 1. So I could write this as 1 minus 1 over L squared. But when L goes to infinity, 1 over L squared goes to 0. And so, therefore, the limit as L goes to infinity of 1 minus 1 over L squared is equal to 1. And so notice how we get a number back. And so we can say that this integral converges. Okay, that's example 1. Let's take a look at example 2. Suppose we have the integral from 0 to infinity of e to the negative 2x dx. So this is the limit as L goes to infinity of the integral from 0 to L of e to the negative 2x dx. So this is the limit as L goes to infinity of, so I'm going to get negative 1/2 e to the negative 2x evaluated from 0 to L. Okay. And so this is the limit as L goes to infinity of, so this is negative 1 over 2e to the 2x evaluated from 0 to L. When I replace x with L, I get the following. So let's write down this next line. We get the limit as L goes to infinity of negative 1 over 2e to the 2L minus, and then when I replace x with 0, e to the 0 is 1. And so I'm left with negative 1/2, like this. So this is the limit as L goes to infinity of Now, if we go back, when you subtract a negative 1/2, that's the same thing as adding 1/2, right? So what we end up getting is 1/2 minus 1 over 2e to the 2l. But as L goes to infinity, 1 over 2e to the 2l goes to 0. And so we're left with 1/2. And so since we get an actual number back, we can say that this integral converges. And that's how we do example 2. Let's take a look at example 3. Suppose we had the integral from -2 to infinity of 1 over x plus 4 dx. So this is the limit as L goes to infinity of the integral from -2 up to L of 1 over x plus 4 dx. So this is the limit as L goes to infinity of natural log of the absolute value of x plus 4, right, evaluated from -2 up to L. Now, let's go ahead and evaluate this. So we get the limit as L goes to infinity of, when I replace x with L, I get natural log of the absolute value of L plus 4. When I replace x with -2, I get natural log of 2. So I'm going to subtract off natural log of 2. Now, as L goes to infinity, natural log of L plus 4 will go off to infinity. Okay? And so here the answer is infinity. And infinity is a concept. It's not a number, right? So when I write infinity here, this is just a fancy way to say that the limit doesn't exist. Okay? And so what we can say about this integral is that it diverges because we didn't get a number back, right? So this integral diverges. And that's how we do example 3. Let's take a look at another one. Let's take a look at example 4. Suppose I ask you the following. Suppose I had the integral from 0 to infinity of e to the x over 1 plus e to the x raised to the second power dx. Okay? Now, just like before, I'm going to write this as the limit as L goes to infinity of the integral from 0 to L of e to the x over 1 plus e to the x raised to the second dx. Now, we can do a u substitution. That is legal, okay? And so I'm going to let u equal 1 plus e to the x. du is e to the x dx. Now, we got to change our limits. When x is 0, u is equal to 2. And then when x is L, u is equal to 1 plus e to the L. Now, let's see what that looks like. So this is the limit as L goes to infinity of the integral from 2 and then to 1 plus e to the L of 1 over u squared du. So the integrand is much simpler. The limits look a little bit harder, but the integrand is much more manageable. So this is the limit as L goes to infinity of. So I get negative 1 over u evaluated from 2 to 1 plus e to the L. So this is the limit as L goes to infinity of. Now I get negative 1 over 1 plus e to the L, so I replace u with 1 plus e to the L. I subtract, replacing u with 2, I'm subtracting negative 1/2, like this. Now, if it helps, we could write this as the limit as L goes to infinity of 1/2 minus 1 over 1 plus e to the L. But as L goes to infinity, 1 over 1 plus e to the L goes to 0. Okay? So this is equal to 1/2. And because we get an actual number back, a fixed number back, that's going to tell me that this integral converges. And that's how we do example 4. Let's take a look at one more example for this video. We'll call this example 5. I'm going to ask you the following, and this is going to look a little weird, okay? But suppose I give you this one. Suppose we have the integral from negative infinity to infinity of x over x squared plus 1 dx. Now, we're going to pick a number in between negative infinity to infinity to break this integral up, okay? So I'm going to pick 0 because it's just nice and convenient. But does it have to be 0? Not really. You could have chosen 1, 2, 3, 1 million for all that, okay? So we're going to go from negative infinity to 0, right? The integral of this. And the integrand is x over x squared plus 1 dx plus the integral from 0 to infinity of x over x squared plus 1 dx. Now, we're going to take one piece at a time. So I'm going to let I sub 1 equal the integral from 0 to infinity of x over x squared plus 1 dx. Now, if that integral diverges, then the integral from negative infinity to infinity of x over x squared plus 1 will also diverge. That's how this is going to work. So we're going to check this first. Now, if it converges, we definitely have to check the first term. So this is the limit as L goes to infinity of the integral from 0 to L of x over x squared plus 1 dx. Now, I'm going to teach you guys a little trick before we continue this. Let's put a note here. I claim the integral of f prime of x over f of x dx. Okay? So the function's in the denominator, the derivative of that function is in the numerator. By a u substitution, I claim that this is natural log of the absolute value of f of x plus c. Okay? We can actually show this by u substitution. Now, I want you to really watch what we have. So we have the limit as L goes to infinity of the integral from 0 to L of x over x squared plus 1 dx. So if my function is x squared plus 1, so f of x is x squared plus 1, the derivative is 2x, right? But notice how I'm missing a 2. Well, that's not a problem. I can put the 2 in. Okay? But to counterbalance that, I'm going to divide by half. Or, excuse me, let me not say it that way. I'm going to multiply by half, not divide by half. So I multiply by 2, I divide by 2, is another way to say it. So now we're set to apply this little formula up here. Okay? So watch this. So this is the limit as L goes to infinity of 1/2 natural log of, now I don't need absolute values because x squared plus 1 has no chance to be negative. Okay? So it's 1/2 natural log of x squared plus 1 evaluated from 0 to L. So this is the limit as L goes to infinity of 1/2 of. So I'm going to get natural log of L squared plus 1 minus natural log of 1. But as L goes to infinity, this term goes to infinity. And remember, natural log of 1 is 0. And so this is equal to infinity. And so therefore, the integral from 0 to infinity of x over x squared plus 1 dx diverges. And if one of the pieces diverges, the whole thing is going to diverge. And so therefore, the integral from negative infinity to infinity of x over x squared plus 1 dx diverges. So example 5 is really interesting. And that'll do it for this video. We did 5 examples of the improper integral, and I will make another video where we will do different examples. So, okay, thank you.